Art. Hello, everyone, and today is mainly about the LSTM. Um, we're gonna go through the LSTM developing a network, a framework or architecture using LSTM that we discussed in our lecture session. So if you remember last week, we talked about the embedding layer, how the embedding layer works. And today we're gonna go through the developing or embedding or integrating embedding layer with LSTM network and see how does that work. So so what we have to do as a start, the same always, the same as before, what we have is to import one database. So here we imported IMDb database, so which is, if you remember, we have already discussed this IMDb database. This is one of the database that is for the movie review. And we have used this data set before in the other workshops. So it's giving us the ID plus, the movie review for the each video. So then, and it's a kind of like and giving us the representation of whether this is the positive or negative, right? So it does have the sentiment label whether this is the positive or negative. And if you remember last week, we discussed about the how we can, use this database. Um, if you remember, we said that once we load the database, we put them into the train and test. It already has the training and testing set. But if you remember, we discussed that we have to shift the data, the tokens. The first three token is the special token that we are considering for these three special tokens. So we give these a special token as the first three token, and then the rest of the token will be allocated to our data set, and then we'll pass, we will load we will have the training and testing data set. So this is the one that we have discussed last week, if you remember. And then what we have here is just visualizing the distribution of the sequence lengths of the data for the training set to find out how is the distribution of the data. So to find out the length of the data, the training set. If you remember in the lecture session, what we discussed, we said that we have to, once we are passing the data, we have to make sure that all the size of the data that we are passing, so they are equal. So then we have to use the padding. So that's why we are getting the length of the data. So we have to make sure that the training data set, the testing data set, they have the same length, right? So through these, visualization to get through the length of the all the token in the training data set, we would be able to find out how is the sequence of the data that we do have for these training data. So you see that we do have up to 1,000, sequence. But the distribution of the data, as we go through between 500 to 1,000, the distribution of the data is not. So mainly up to 500. So the most of the data that we do have, they are mainly up to 500 token, right? So then to get through what I said is that we have to get, when we are, using the LSTM model, so what we have to do, we have to make sure that the training and the testing data set, they have the same length. So then we are passing them to the deep learning model, right? So here, if we get 500, then it would be a good, number that we can consider as a maximum length for the sequence of the data. So for each movie review, for each sequence of the data, we can define a maximum of 500 lengths, and then we can, truncate those excess token, right? So we can get rid of those. So we can reduce it down to 500 token to make sure that the length of the data that we do have for training and testing can be the same. So how we can do this adjustment is going
Just
through
very
the
quick question, like
Mhm,
so the so if we treat the sequence as a sentence, right? Let's say
mhm,
um, so the length of sequence is the number of words in the
yep,
sentence, right?
yep.
Um, so that's x-axis, right? So you could have 500 words or
Yeah,
1,000 words.
yeah.
What's y-axis here
What is y-axis? What do you
in
think?
the graph? In this graph,
This is the number of the tokens that we do have. So if we do have the how many words are repeating, right? So this is showing us the number of tokens that are repeating, right? So go back and check the IMDb
okay,
data set, right? The IMDb data set shows us the frequency, right? So it shows us the frequency of those tokens.
like how many
So
times they
how
are
many
repeated in the
times
entire
are
set.
repeating in the entire data set?
Right. Okay. Understand. Thanks.
No worries. So if you want to pad the data, so if you want to get through the length of or get the same length for the whole data set that we do have, so one of the function that we can use is the pad sequence through the preprocessing libraries, through the preprocessing function. We can call the pad sequence function that is going through the checking or padding the or reducing or expanding the whole, the sequence of the data, those 500 token that we are talking. So if you are getting all the sequence of the data for the, one of the movie, so then once we apply the padding on that data, then if the length of the data is less than 500, then what would happen? It will add 0, right? If it's bigger than 500, it will just cut it, right? So then we will apply this padding sequence to both training and testing data set, and then the maximum length is 500 token, right? So then after applying this pad sequence, both, training and testing data set, we will have the same sequence of the same length, right? So exactly it will be 500 token for the, this is the one that you have to make sure that you are applying for deep learning model, because they need to have the same length always, what we are using for the deep learning um, technique. This is the same as before. If you remember what we said, we have to embed the data. What we mentioned, we said that the data that we do have is a text, right? And then the data, the machine only understand the digit, right? So we have to apply those embedding. That's why we said that we can have those one hot encoding, or we can have embedding layer. So we are trying to convert essentially words to some, numerical um, representation, right? So this is that's why we are using the embedding layer. So then what we did have for the as part of the embedding layer, this is what we discussed last week. So for the embedding dimension, what we said if it's we are defining the embedding dimension as 100, what does this mean? It means that we do have the embedding vector with the size of 100, right? So then we do have a vector with the length of 100, right? So then this is what we are getting for each row, for each sample of the data that we do have. So considering that if we do have each row is one movie review, then we will have for each token, we will have um, a vector with the length of 100. So what we have, we said that for each movie review, we have 500 token, right? And each of those, each of those token, they have a vector of length of, 100 dimension, right? So this is what we are getting as part of the embedding layer. So this is, part of the cross layer. So if you want to create an embedding layer, as we discussed last week, is part of the cross. So you can define the embedding. And what we do have, we just need to define the maximum features and then the embedding dimension. So the maximum feature that we do have, what does that for? So it's showing us what is the number of the vocabulary or the kind of like the words that we do have. So for the IMDb data set, what we have imported up there, so we said that the number of words to consider is 10,000 the most frequent word, right? So then we are getting as part of the IMDb data set, we are getting the 10,000 most frequent words in the IMDb dataset. So here, what we do need as an embedding layer is to pass the number of words in this case that we do have 1,000 most frequent words in the IMDb dataset, and we do have the embedding vector that is 100 in this case, right? So we do have this embedding layer, and this is I just copy and paste here. And then we have, we want to use this embedding layer into the LSTM network, right? So what we have to define a model, right? So if you define a model, then the same as before, we have the sequential model. So what we have for the sequential model as part of the cross, so it is let us to create a model, to build a model and stacking the layer. So we are adding the embedding layer. Essentially, this is the one because we do have the text data. So we are adding the embedding layer. And then what we do have, we have 2 layer of LSTM network plus a dense layer. So what we discussed, the LSTM is part of those RNN network. We discussed them yesterday even in the lecture, which is for the sequential data as we are using the sequence. So as we are having get data with the sequence of the data, so then the series or the order of the data is important. So then what we do have, then we are applying the LSTM as part of the cross layer, right? So we are passing the 32. What is the 32? What's the meaning of the 32?
Is it the neuron?
Yeah, exactly. So this showing us the number of unit or the number of cells that we do have that layer. So it will help us to capture for the capturing the pattern of the data, right? And then what is the return sequence? This is one of the other parameter that we discussed in the other workshops. So when we do have the or workshops, yeah, and as well as the lecture. So when we do have the return sequence as true, what does this mean? If you see, as you can see, we do have these return sequence in the first layer of LSTM, but we don't have it in the second layer of the LSTM. So what does this mean? When we do have the return sequence as true, it means that if you remember for the RNN, what we discussed, we said that if you want to pass all the output from the, in a full sequence of the data that we do have, to pass them to the next layer, if we do have two recurrent neural network, LSTM is one of the other type of the RNN or recurrent neural network. So if we want to pass, as we do have two layers of the RNNs or two layers of the LSTM, then what we have to do in the first layer, we have to pass all the output of the, the full sequence of the data to the next layer, right, as an input. So that's why we have to pass, we have to make this return sequence to true. And then for this for the second layer, as we don't have any other recurrent network, after this and it's a dense layer, then what we have to do, then we don't need to pass it. So only the output of the, the final output, the last one for the sequence of the data, if you consider the entire sequence, the final output of the sequence will be passed to the dense layer. So we do have a dense layer here after the LSTM, and then we do have one, unit output here as the final layer for the output. So this is the one that we do have. It's showing us this is a binary classification, right? So we do have a single value as an output. So it's showing us whether the output is positive or negative. So the movie review, what I said, the output of the movie review was positive or negative. And as you can see, because this is a binary classification, the activation function here is sigmoid. So it is a binary classification problem, right? And then based on that, we do have the a sigmoid function. So the output that we are getting out of the sigmoid function, I also mentioned this in the lecture session yesterday, the sigmoid function, and keep reminding you, sigmoid output is a probability. So it's giving you a probability between 0 and 1, and that's showing you the the probability of the review that is being positive or negative. So if we do have a threshold, let's say 0.5, if it's below 0.5, it will be negative, and it's greater than 0.5, it will be positive, right? So then the output for the dense layer, this is what we discussed yesterday, DNN network. So which normally will be used for the classification purpose, right? So then if we consider this as our model, then what we have to do is just to kind of like create the model. We are just calling a model and then getting the summary. So what you can see here, you see that the output shape, the parameters, they are all 0. So what's the reason? Do you know? It's not showing us anything related to the output shape, the parameters, the number of parameters. You know what is the reason? Because what we do have, the model here is not created yet. So then the output, the input layers is not passed to the model yet. So when the input model is not clearly defined here, then the output, so then the model is not able to give you what is the shape of the model, then it's not able to calculate the number of the parameter. So because we do have the embedding layer here, and then through the cross library, if you don't define the input dimension here explicitly in the in the model definition, then what it does, it's getting through the until model feed, then the model start the training, then the model will, because it will understand what is the input shape. So based on the input shape, it will go through the all the models and then giving you the output shape and giving you the parameter. So here we haven't defined the output, the input shape for the embedding layer. So it's not clearly mentioned here, right? So what would be the dimensionality of the input shape? So then until it doesn't give you any kind of like an error. It does, because you are passing the training data here, and based on the training data that is passing to the feed model, then it will calculate, or it will know what would be the output shape and the number of parameters. So if you go back to the previous lecture, workshop, you'll see that we have defined the dimension of the input layer. So then that's why you will get the model summary clearly. What is the model summary? But then once we create a model, then here what we need to do the same as before, just an optimizer. So what is the optimizer that we do have? The optimizer that we have is RMS prop, so root mean square propagation. So it's one of the optimization technique that we are using. And generally we are using this RMS prop for adjusting the learning rate, right? So the one that we discussed yesterday, for based on the what we are doing, we are using the model training based on the gradient descent. So then what we are doing, so we are trying to adjust the parameters. So the one of the parameters is learning rate, right? So how we are adjusting the weights. So it's one of one of them that is showing us how the model has to jump, or how sharp or how smooth they have to move forward. So based on the learning rate. So and learning rate here is the will be optimized through the RMS prompt. So we are using these for updating the weights based on the loss function that we do have. And then here what we have as a loss function, the loss function here is binary cross entropy. We normally use this binary cross entropy for the binary classification problem, and then the metrics that we are using is accuracy. So what we have to do, we have to pass the training set, as we said. So then we do have the Y train, X train, and the training data set will be passed to the model. So the number of epoch is 10, batch size is 128, which means that every time the 128 sample will be passed to the data, right? So then and then here the validation split is 0.2, which means that 20% of the training data set will be allocated to the validation set for model, during the time of the training. Then for the evaluating the performance of the model during the process of the training, then will be applied on the validation set. So then 20% of the training data set will be allocated to the validation set for model training part, right? So if we get the model to train, and here what we are doing, we are just getting through the visualization of the model. So what we have, we are visualizing the training set as well as the validation set for both accuracy as well as the loss. So if we get through the model evaluation, how do you see the model is performing?
The performance is overfit, I think, because the
Mm-hmm.
loss increase and the validation after epoxy it decrease, and after A it is increase a bit, but the gloss is still increase a lot. So I think it's overfitting.
Yep. Correct. So the model is overfitting, as you can see, as the number of, epochs is increasing, then the model's performance, so the accuracy for the validation set is decreasing. And then what we said, always, if you want to see that the model is performing well or overfitting, is that if the gap between the validation um, result and then the training results are small, if the gap is small, then it means that the model is performing well, is learning. If the gap is high, is getting is keep increasing, it means that the model is not uh, learning, right? So then as the number of the iteration increases, so then the validation loss is increasing. So we are expecting to get decreased, but it's increasing, and then the accuracy is decreasing. So that's why the model is not performing well, right? So the model is not learning. So here, um, if you remember last week, we discussed also how we can get through the embedding layer through the pre-trained technique. So we discussed that we can, download the glove model. So we are able to get through the embedding or glove board embedding pre-trained model. So we just need to use the WebGet or WGet. So just getting through the model, um, downloading the pre-trained model. So then the glove model, this is what we discussed last week. So it's exactly the same as last week. If you go back, you'll see that we are just getting access to the glove model, and it's a zip file model. And if you remember, we said that once we are, downloading the pre-trained glove model, and we are putting them into the temporary directory, then you see that there are a lot of different, glove model that you can get access. But what we do need is based on the dimension, the vector that we have defined 100 for vector, right? So we just need to get through the one that is compatible with the vector dimension that we have defined. So here we do have 100 dimension as well. So what we need to do, we just need to get access to that one. And if you remember, we said that to get through the processing with the deep learning model, we have to change the type of the data to the float to make sure that the data is working. And here we are just getting through the embedding vectors from, the glove model. And if you remember what we have done, this is exactly the same. So if I'm not going to every detail of it, because we have in detail, we have discussed them in last week session. And if you remember what we said, we are trying to map, or we are trying to find those 10,000 most frequent words from the glove data. So from the glove embedding data that we do have. So we are able to get access to the embedding vector of those 10,000 words from the IMDb. that are, you know, in the glove. So, and we are able to put them together. So, and creating the embedding metrics. So essentially these embedding metrics representing the embedding vector for the all those 10,000 most frequent words of IMDb dataset, right? So this representing the embedding vector. If you remember, so up there we are, you know, developing these embedding layer or these embedding vectors from scratch. But here, rather than just because the model didn't learn well, so then the embedding vector is not, you know, good enough here, then we said that let's do, you know, the same, the same modeling with the pre-trained embedding, word embedding technique. And what we need to do, we just need to get access to those embedding vector for those 10,000 most frequent words, and then just set the, you know, weight for the embedding layer, right? So here the embedding layer now is set, though the weight for the embedding layer is set based on the pre-trained glove word embedding vector. So that we have, you know, now. And if we create the model or just reinitialize the model using these embedding layers, so nothing has been changed other than the embedding layer. So we are just setting the weights for the embedding layer. And then if you call the model again and just train the model using these pre-trained embedding layer, we'll see that how is the result is changing. So this is the result for the model, the same as, you know, up there, but then the only difference is that the word embedding layer is based on the glove. So now you see that the difference between the previous, you know, model performance with this current, you know, model performance based on the glove, pre-trained glove word embedding technique. So as you can see, as a number of the epoch increasing, so then the it is not as, you know, ideal, but it is better than before, right? So then the accuracies are what we are expecting. If you increase the number of epoch, you should be able to see that the model, where the model is converging and how the model is changing. So if you see that over, you know, as the number of epoch is increasing, the model is not converging, then it shows that it's not a good model. Maybe you have to refine the architecture, but if it's converging, then you will be able to find out how the model is performing. So we are expecting to see that the loss value by increasing the number of epoch should decrease. But if you remember what we discussed in the lecture, right? We said that, you know, one of the techniques that we can add to make sure that the model is not overfitting in the recurrent neural network is to add dropout. The same as, you know, the previous deep learning technique that we discussed. So we said that we can't apply the normal dropout in the LSTM layers or the recurrent neural network layers, and we have to apply they do have the recurrent dropout technique that we can use in the LSTM layer to make sure that the model is not over feeding, right? So then this is one of the techniques that we can use to control the overfitting by adding the recurrent dropout to the LSTM layer. And of course, we should add the dropout before the dense layer. right? So if you train the model again, you see that the model's performance is not improving that much, right? So then this shows us that the model has to need more refinement. So you have to go through the model refinement, but then increasing the number of epoch is one of the ideal um, techniques that you can use to see that if the model is learning or not learning, right? So one of the other techniques is to um, use a bidirectional LSTM, and this is part of your exercise if you want to find out what is the bidirectional LSTM, the same as the model that we are having here, just we do have the bidirectional LSTM rather than the LSTM. And what you have to do, you have to just build a model using the LSTM. So this is part of your exercise. But yeah, this is for today. Happy to answer any question.
So can I like question around the embedding layer, right? Sorry,
Yeah.
this might be a very basic question.
Mm-hmm.
I need to listen to the last week's session completely, like the
Yep.
workshop.
Yep.
Um, the embedding matrix that we added, right? That's from the glove. Um,
Glove
uh,
here.
so if you
Glove.
look at the cell where we set weights to the embedding layer,
Mm-hmm.
yeah, that's from the embedding matrix, right?
Yep.
And the embedding matrix is from glove, which is pre-trained
This is the
vector representation. Yeah.
yeah here. If you want, I can go layer, by layer. So what we have here, if you remember what we are doing, we are just downloading the glove layer, right? And then what I mentioned is in the glove layer, if you remember, we said that once we download the glove layer, embedding technique models, you will be able to see different dimension of the glove, right? So we do have 50 dimension, 100 dimension, 200 dimension, and there are a lot of, once you are downloading, putting them into that local zip, then you would be able to see that we will get different glove. So because the dimension that we have defined is 100, right? So then that's why we need to get access to the 100 dimension for the glove, right?
Yep.
And if you remember what we mentioned, as part of the these glove, so we do have a word plus coefficient. So the word is showing us that the exactly that words, right? So that we do have, and then the coefficient essentially is giving us that embedding vector, right? So
Yeah,
then the
it's the
coefficient
is the vector representation of that word, right?
exactly. Yeah.
So like if two words are have a same sort of similar meaning, they probably are close in
Mm-hmm,
this representation.
mm-hmm,
And if they are diametrically opposite, they are far away from a similarity
exactly.
point of view, right? So this
Exactly.
is like a vector representation of those words,
Exactly.
which according to Glove, right?
Yep.
Now my
Exactly.
question is, we have taken the 10,000 words from our IMDb dataset.
Mm-hmm,
Then we took the vector representation for those 10,000 most frequent words, and then we built a matrix, and we are calling it embedding matrix, right? Which is in that cell, right?
here we are not creating, yeah. So what we are doing, we are just this is the all zero, right?
Yeah.
So we are just creating that one. And what we have to do you remember what is ID to word?
Yes, it takes the index and then gives you the word
Oh,
of
exactly
that
all the
index. Yeah.
words that we do have. And then from that word, what we have to do, we just need to get access to that coefficient. Exactly. So what we are getting, essentially, we are getting access to those embedding representation from the glove based on,
Yeah,
let's say
for
if
those
we do have,
10,000 words.
exactly. Yeah,
Yeah, I understood that. And then we are adding weights. We are setting weights of embedding layer using that matrix, right?
exactly.
And then, okay, now I'm coming to my actual question. Actual question is like when we create the model and then we
Hmm.
compile and fit the model,
Hmm.
would the embedding layer again adjust the weights? Because we already have a representation of these
Yeah.
words
So
in
it's
vector space, right? Would it
so you mean that
change?
it's
Yeah.
going through the retraining? Yeah. So
Yeah.
it's the model that we do have. They are retraining. So it's getting through the changes. Of course, it's getting through those changes. But what would happen? It's not learning from scratch because the model that you do have, it's the one that we do have up there. This is exactly, no, really good question. What we do have here, where is that model? Here. So what we do have here, we are initializing the model randomly, the weights randomly for the embedding layer. So that's why the model, so during the process of training, the model has to adjust those weights. Those vector representation has to be built, right? The one that is
Mm.
here, because it's learning from scratch, doesn't have any good understanding, but the one that we do have, when once we use the glove, it does have a good understanding and is shifting a bit based on the data that you do have, right? If you remember what I mentioned in the lecture session, what I said, it is the context based, right? So the one that you do have, the glove, is already trained on the general database, right? And then once you use them, you are essentially retraining that one, but you are not retraining from scratch. So consider that you are learning the model, the same as here, what I mentioned. Consider that you are getting a good model, that the model always, over the, as the number of epochs are increasing, the model is getting better and better. But it's not moving or it's not shifting that much. So you see, this is a kind of like a big jump, right? If you are getting a good model, the model shouldn't get these big jump. So the model smoothly is learning. And then because as you can see, once we are getting this one, it does over the time is getting better and better. So it's, shifting the changes is not that, big enough, right? So based on the data that we do have, the model is still retraining. And then as you increase the number of the epoch, then the model will become better and better. But it's not the one that we are freezing that layers. It's not frozen.
Yeah. Understand. No, no, it makes sense. Thanks.
No worries.
And in terms of the dropout that you added, right? That hasn't improved the performance or anything,
Mm. Mm-hmm.
but it
Yep.
hasn't also created a huge gap between training and validation loss slash
Yep.
accuracy.
Yep.
So it sort of proves that it is more generalized.
Yep. And then,
Okay.
what we do have here, it's showing us the model that we have developed might not, complex enough, right? So what we do have only one LSTM layer, right? And then we do have just the dense layer, right?
Mm.
So then just one LSTM and one dense layer. So as we are just getting through the model performance using one LSTM layer for this sentiment analysis, it shows that the model might not, is complex enough to learn the pattern, and you might have to add more layers to find out whether, the performance of your model is changing or improving, or the, how the model is changing by increasing the number of, epoch, changing, the batch size. So these are the kind of like the, always different, parameters that you have to optimize them, and you have to go through the trial and error to evaluate the performance of the model and see how your model will be generalized, on the training data that we do have.
And also, if you don't mind, can you explain the padding sequence, that code that was added in the first 3 cells? And also, why do we add, the special padding tokens? Sorry, I did not quite
Yeah, so
follow
for the,
that.
what we have always in the deep learning model, what we have to do, because the sequence of the data, let me bring up a paint. See if I can draw. So let's say this is our training data set, right? I'm just considering that if this is our training data set, let's say that we do have only for the first row, right? This is the size of the data. For the second one, this is the size of the data. For the third one, this is the size of the data for the, the rest, right? So
Keep it
then we
consistent
might,
length.
yeah,
Okay.
so there is an inconsistency in the, so consider that this is, would be, has to be the, okay, so but consider that this is part of it. So then there is an inconsistency in terms of the number of, the size of the data that you are getting, right? Because the one that you do have. So what we have to do, we have to always, we have to send a data with the fixed frame, right? So the length of the data has to be the same. If we do have, let's say, the data here that are even longer, right? Then what would happen? Because what we have to do for the deep learning model, we have to always send the same length to the data. So that's why we have to apply the padding. So this is the reason, and this will happen most of the time in the time series data analysis. For the time series data analysis, let's say you are working with the signal, right, data. So the signal data that you are getting, let's say if you are getting the signal data, for example, the ECG or the heartbeat, the heart activity data from 20 subjects for over, let's say, 2 minutes, right, or 1 minute. The size of the data that you are getting, it might be different because there might be some missing value. There might be, some noises in the data. Always the data that you are getting, it might be, different in size. And always we can't find the exact timing, for the data. So that's why we are applying the padding in the data. So if there is a kind of like if there is any missing value in the data, then we can apply padding, or we can, apply some imputation technique to fill the gap, because what we have to do, we have to always send the data in the same length to the training and the testing data set. So that's part, the padding come to the picture, right? And then if we do have the data that are, smaller, then we can, apply 0 here, right? So we fill them with 0. There are different techniques that you can apply, right? So it's really, depends on what you want to do. So whether you want to put them, keep them with 0, or whether you want to apply some imputation technique and add those, values. So let's say, for example, you can apply some average and then fill those gaps with the padding. But then padding means that you have to make sure that the size for the input data would be the same. So, and then those ones that are kind of like an longer, then it can be ignored, right? Depends on what you want to do and how much those data are important to you. Because let's say if you add here, if you if we kind of like tell me, Bahar, why you cut them here, why you didn't add here. Let's say if you do have a lot of raw data, a lot of samples, that most of them they will be finished up to here, and then just a couple of them they have longer, lengths, then we would say that it's better to cut, have the cutoff from here other than here, but because otherwise we will get a lot of zero. But if there are not many samples, then you can increase the padding. So that's why if you see that the one that we discuss here, so the number of the sample or the kind of like the sequence of the data between 500 to 1000 is not that um, that much. So then that's why we use the cutoff for 500 token, right? So for 500.
So that's number of sequences
Mm-hmm.
between 500 to 1000 words, right? That's what it means,
Yeah,
is less.
yeah,
Okay,
yeah,
okay. So the sequences with between, let's say, 100 to 350 is more. Like
yeah.
there are
So
quite a lot
then
of
the
sequences which in
less
between.
data
Yeah,
will get zero,
yeah.
value.
Okay, okay. Understand. Understand. Makes sense. Thank you.
So this padding is one of the very important parts into your pre-processing steps in the time series data analysis. So regardless of whether it's text or any other type of data that you are getting, if it's time series data, most of the time you will have this issue that there is an inconsistency between the sample data that you do have. So then you would require to get through the padding, and this is the only this is one of the pre-processing techniques that you have to consider.
Yep, makes sense. Thank you.
No worries. Any other question?